collaborators in the last time. Stacey, Virtue, Altera Sanders, and Kevin Hubble. We're talking about seagrass nursery habitat function, relative effects of structure and prey density, and Mesopredator foraging efficiency.
Good morning and welcome. Now we've all heard some amazing talks so far this weekend about cutting-edge research going on all across campus. And one of the main goals of this research symposium is to not only present our research, but to do so in creative and interesting ways. So, inspired by Dr. Jeremy Wong's 2010 Synthetic Ecology Webinar, my co-author, Miss Stacey, Virtue, and I, well, we've decided to do just that. Hey, what's up, SDSU? We bring it to you. They call me a Warneke, and this is Virtue.
We be busting out the rhymes, keeping up with the times. We rep the field of biology and seagrass ecology.
Looking at habitat behaviors changing with that, effects of structure and prey on predators foraging all day. These critical sea plants have huge significance.
For juveniles, this nursery is the safest place to be. Till recruitment to the kelps, the seagrass truly helps. Seagrass density, it varies greatly, which adds to its structural complexity.
Looking for grub, and the success thereof is altered by grass shoots found in these groups. Many do think that there may be a link, a decrease in success when structure is complex.
But these assumptions don't account for grass and prey changing amounts. See, these factors can co-vary, which caused us to be wary.
This brings us to our objective. We took a new perspective, interacting a change in complexity and prey density, and how both predator and prey could be affected by these.
So with that information, we felt inspiration. This is what we thought would happen during experimentation. Our hypotheses, we predicted just three. The first being about the level of predator activity. You see, we assumed this would decrease with an addition of structural complexity.
Number two's up next. You'll read the text about predator-prey encounter rates and foraging success. We predicted a decrease with more complexity, but only an increase with prey density. Last on the list, but not to be missed, we finally break down our third hypothesis. We think this will be the prey, they won't flee. Escape attempts will decrease with increased complexity.
Our collection site, yeah, it's pretty fly. 2 seagrass beds right offshore when the tide is high. Shelter Island, we be repping it all night and day. Using nets, we gathered specimens in SD Bay.
The species we inspected cannot be neglected. Heterostricus rosterus is what we selected. Of these juvenile kelpfish in seagrass, there are plenty. We use sizes from 85 to 120.
Now moving on to the prey, it's the Hippolyte. Abundant in the bay, all the fishies say, hey!
Experimentally, that could be Symposium's constructed. We use polypropylene ribbon to create seagrass beds for swimming.
The setup was this, fully cross treatments. The first consisting of a density of 7.5 shrimps. The shoot density of which there were 3 low, intermediate, high, to which the shrimpies clung by.
Now we use that same trick, increase the number a bit. We upped the shrimp game, but kept the seagrass the same. 300 shrimp there now be to rep the high density.
Each trial consisted of 2 predator fishes foraging in the Mesopredator on set number of shrimpses. 2 people observed each trial and recorded into 5 categories. These behaviors were sorted.
Number 1 was defined as the proportion of time fish that actively swimming, and I can't think of a rhyme.
Which we inspected how many prey were detected, then recorded how many fish strikes were attempted.
Number 4 we would score if strikes were a success, followed by escape attempts by shrimps. These behaviors we'd assess.
Now just to take it back, let's do a hypothesis recap. The first one of just 3 about predator activity, that levels would decrease with structural increase.
That was the first section of our results. We were looking at predator activity in regards to the same changing seagrass densities we explained earlier. With percent of predator time spent in motion on the y-axis, and seagrass shoot density on the x. Again, we use low, medium, and high complexities. As with all of our graphs, the light green bars represent the low 75 shrimp prey density, and the dark green bars represent the high 300 shrimp prey density. Now looking at the data, we can see that there is not a drastic difference in activity levels between the low and intermediate complexities. The same holds true for both the high and low prey densities across all treatments, showing us that there was no effect of prey density on kelpfish activity. In In the high complexity, however, we see that there is a decrease in kelpfish activity, bringing us to the conclusion of our first hypothesis, that kelpfish activity levels decrease with the highest level of structural complexity. This leads us to the belief that there might be some sort of threshold level of structural complexity where fish mesopredators may switch their foraging modes from actively swimming to a sit and wait behavior. Number 2's up next. You'll read the text about predator-prey encounter rates and foraging success. We predicted a decrease with more complexity, but only an increase with prey density.
So in this section, we are focusing on our predator-prey encounter rates and our predator foraging success and how they are affected by structural complexity. But first, we will just focus on our predator-prey encounter rates, which we've here defined as the number of kelpfish strike attempts on prey. Now, prey detections and kelpfish strike attempts were highly correlated in all treatment combinations because in order for a kelpfish to attempt a strike, it would have had to have first encountered the prey. So with seagrass shoot density on our x-axis, but this time the number of strike attempts on the y-axis, we can see that in the low, medium, and high complexity levels, there was no significant difference of predator-prey encounter rates with seagrass shoot density. However, as the density of prey increased, so did the number of strike attempts. So next we will focus on the results that we predicted from our second hypothesis. So this time with seagrass shoot density on the x-axis, but proportion of strikes that were successful on the y-axis, we can see that with low prey density, as indicated by the light green bars, that there was a decrease in the proportion of strikes that were successful only in their intermediate complexity versus the high and the low. However, at high prey density, which we can see by the dark green bars, there was no significant difference of the proportion of strikes that were successful among the different seagrass treatments. Therefore, there was an increase in proportion of strikes that were successful only in the intermediate structural complexity, which brings us to the conclusion of our second hypothesis. So what we saw was that there was an interactive effect of prey density and seagrass shoot density on foraging success by kelpfish. Last on the list, but again not to be missed, we finally break down our third hypothesis. We think this will be the prey, they won't flee, escape attempts will decrease with increased complexity.
Now in our final graph, we're looking at prey escape attempts in regards to both structural complexity and prey density, with proportion of detections resulting in escape attempts on the y-axis and seagrass shoot density again on the x. Now, even though we hypothesized that prey escape attempts would decrease with an increase of complexity, we found that this was not the case, as there was no variation in prey escape attempts across all three treatments. Overall, structural complexity did not have a strong overriding influence on encounter rates, the ability of mesopredators to capture prey, or the decisions by prey to escape from predator attacks. To wrap up, we'll give our final mashup. Our message you now see be about structural complexity and how the predator-prey encounter rates did not vary.
The rates that we will say varied with density of prey. One more thing we must press about predator foraging success, and that the behavior is affected when prey and structure are interjected.
These last points we will make from our talk we hope you take.
We found that it is necessary to quantify relationships between structural complexity and prey density when assessing the mechanisms by which structure influences predator foraging success and, conversely, prey survival rates.
We also see that inverse relationships between structural complexity and prey density cannot be assumed.
And finally, that these concepts will play important roles in dictating the ability of seagrasses to enhance the survival and growth rate of juvenile organisms, as well as their recruitment to adult habitats.
All these peeps we'd like to thank to our lab and to our bank. A final thanks to you, we shout. It's been real, stay peace out.